Hey YouTube, it's been a while, but I wanted to start making some content for you guys again. First things first, I want to address the elephant in the room. I want to apologize for my poor camera quality. I don't have my usual camera with me right now, but I didn't want that to stop me from making this video. So please do bear with me. Now, one of the first videos that I made on this channel, one of the first videos that I posted, um, was a function decorator that would automatically, when your Python program crashed, would open up a web browser, would do a Google search, and would show you Stack Overflow posts for that error to help you resolve it. And I've heard that that was something of a lifesaver. But in more recent years, really the last year, developers have started to move away from Stack Overflow. Now, don't get me wrong, it's still a very useful tool, but developers have started to move away from it and instead are relying on LLMs and other code generation technologies to help them debug and even write their code. So in order to stay current, to stay modern, to keep this solution feasible, I want you to dare to dream for a second. What if you could get an explanation of your bug and potentially even do the complete debugging step without ever leaving the comfort of your IDE? Now, if you're using something like GitHub Copilot or one of these fancier tools, that's definitely possible. But what if you were just using something like the idle shell? Could we still do it there? I want you to dare to dream about that world, and I'm going to show you a solution that I've cooked up right now. I just want to show you what this thing's going to look like when it's actually running, and then we'll take a look at dissecting the code to see how exactly it's working. But before we do that, let's just run this in vanilla mode, and we'll see that there's a pretty basic error here. I'm trying to sort a string, and anybody that's even slightly proficient in Python knows that, well, strings are immutable, and it doesn't even make sense to try to sort them. So if I run this, I'm going to get this error. And anybody that's familiar with Python is going to know that first you get the trace back, so where exactly did this error happen, so we can follow it back to its source. But then we also get the type of error down here. So this is an attribute error. And string, like we just talked about, has no attribute sort. So now I'm going to apply the smart error decorator, and we're going to see what difference that makes to the code. So or to the output. I'm going to run it again. And it took it just a second longer, but we see now we've got three distinct parts in our error message. The first part, which is this kind of yellow color, is the trace, and we'll notice it looks pretty much the exact same. The line numbers are different because when we added this little header here, it moved them down. But then we've also got the error, which is now very prominent, and it says the same thing. So this is the type of error that we encountered. String object has no attribute sort. That's fine. But now in blue, we've got something new. This is the assessment, and it's telling us what exactly went wrong here. So the error str object has no attribute sort means that you were trying to use the sort method on a string object, but the sort method is not available for strings. This is because strings are immutable, meaning they cannot be changed. To solve this error, you could convert the string to a list using the list function, sort the list using the sort method, and then convert it back to a string using the join method. So, for the sake of argument, why don't we try that? So, we will do exactly what it is suggested. And we'll run it again. And we'll see we got an error. You can only join an iterable. Okay, that's because we can't do... This is a common mistake that happens. .sort is going to return none because this is actually mutating the list. Instead, we should have done the function sorted. So there's a little free tip to go along with this. Okay. And why don't we save that and print it? So there we go. Now they're in alphabetical order. They're sorted. So this was pretty helpful, and it gave us a suggestion that we might not have thought of, even for this kind of trivial toy example, it came up with a way to make it work, and I guess whatever it was we were trying to do. So you could, in theory, use this for any function as long as you put this decorator at the top. Now, unfortunately, this solution still needs a decorator, but maybe later we'll talk about ways that we can even get around this, and we can just replace the overarching error mechanism with this kind of a thing. But let's actually dive into the code and see what's actually going on here. How did this work? So one thing that you're going to need for this, if you're going to try to run this on your own, or you're trying to code this up on your own, you're going to need to go and have an OpenAI account, and you're going to have an OpenAI key, an API key. So that's what this little token.txt is over here. Now I'm not going to open it because then you're going to get to see my token, and that's no good. I might as well just show you my credit card and my social security number while I'm at it. But you'll need to get your API token. And if you need help with that, post it in the comments. Maybe I can even make a video about how to get all that set up. But you're going to need to make an account and get a token. And in fact, that's what this first function does. It reads in the token. So it goes to that file, reads the token so that I can use it. And this is just good practice. Whenever you're doing any sort of program that's going to require an API token or a secret key or a password or anything like that, don't store that as a string, like hard-coded into your code. Instead, put it in a file somewhere else, and then make sure you put that file in your git ignore if you're going to be pushing this thing to GitHub. Because you don't want to accidentally leave it there and then have everybody and his brother have access to your account. So get used to this idiom of reading in these kind of secret bits of information. Then we've got another function here that's called Ask GPT, and it takes in the prompt, and we'll get to that in a second. But what this is doing is actually using the API. So we want to use this model. This is the prompt that we're giving it. This is the maximum response that we want in tokens, and so on and so forth. You can read the documentation to know exactly how to use the OpenAI API. And then we get explanation and solution. So this is actually formatting the prompt for us into a way that the API, the model, can understand. Then we do the asking, and then that's going to return a JSON file. Most APIs are going to return a JSON file. So we got to play around with it, look at it, see what's in it. And I did all of that off screen to figure out the relevant information that we want is choices. We want the first one. We want the text from it. And then in case there's any sort of new lines or spaces on either side, I go ahead and strip that off. Now, the real meat and potatoes of this is that smart error function. This was the one that we were using as the decorator. So as with all sorts of decorator functions, it's going to have this internal nested function with its args and its quargs. And really, it's the same thing as the Stack Overflow example that we did in the previous video. So it's going to return this new function that it's building, or it's going to try to run it rather, and then return the output. But if anything happens along the way, we catch it. So we're going to catch that exception. And right now I'm just using a base exception, but you could probably do things a little bit more sophisticated here if you wanted to. This project is really just a proof of concept, and there's a bunch of different ways that we could take this. Once we've got the base exception and we know what went wrong, and we know that something did in fact go wrong, we're going to grab the API token. This is a little bit inefficient. If you're going to do this like large scale, you'd probably only want to grab the token once, but we grab the token every time an error occurs, which is fine because actually your program should only crash once, because if it's crashing, it's done. So this isn't too bad. Anyway, we get the token. Then we call this get explanation and solution function, and we pass it E, which is the error. So E is the problem. We give the problem to the string formatting here. If you're not familiar with this notation, this is a way that you can do string formatting without the F string. And this is what the prompt looks like. So we could have just as easily used an F string, but this little %s says, save me some space here. I want to put a string there later. So the prompt is, give me a short and concise explanation and potential solution for this error. And then we provide the error trace, or the type of error. And then this is the explanation that's returned, which is what we see down here in blue. Then we got to actually format this response. We got to make our own error message, because this is not what it looks like when we get it back from ChatGPT. So we get the format of the exception, or we format the exception rather. Let's actually look at new error before we get into this too much. So new error is another string that we're formatting, and it's got these different color codes in it. So these are little character sequences that you can use in your terminal to actually color them. And there's a whole list of these. You can just look them up, and you'll see the entire table of the different colors that you can choose from. These are the ones that I chose just as the proof of concept. So we see that we're going to start with yellow, and we're going to make the trace. There's a placeholder for the trace, which we get from this. The trace back, and then we format it so that we can print it. And the next thing is in red, that's the error. There's the placeholder for it. And that's the actual exception. So that's this little error here. Can only join an iterable. And then we get light blue. This is the assessment. Got the placeholder. That's the explanation. That's what we got back from ChatGPT. And then we reset it. So if we're going to print anything else to the terminal, it can be its normal color, whatever color that was before. In my case, it would be white. So you can do this for many other things. It doesn't have to be related to OpenAI or LLMs at all. But I just thought it made it look nice and made it easy to visually parse the different pieces. This is where the error happened. This is the exact error. And this is a potential fix and explanation of what went wrong. Then we actually print it. So this is the output that prints to the console. And then lastly, we close the Python program because we don't want to continue. Sometimes you're going to catch the exception and you're just going to continue your program. It's not going to be the end of it. But here we actually want to crash and we want to end things. We just wanted that nicer, better output. So we're going to do sys.exit. And that's how we can get output like this. And for a little toy example like this one, where we were just trying to sort a string, you're not going to need something quite this complex or this advanced, right? But if you're dealing with a third-party module or something that maybe you're just starting to learn, and it could be more complicated, or maybe you're dealing with a library that you're building that's got many, many files in it, this could potentially be helpful and help you debug. Now, a couple of directions that this could go in the future, and if you guys are interested, drop a comment below and maybe I'll make another video following up on this. Or even if you have any of your own suggestions, put them in the comments and we'll see what we can do. But it might be nice if it also had some context as to the files that you're dealing with. So is there a way that we could actually grab the code that's immediately surrounding this pain point and put that in the prompt somehow so that it has a point of reference? Also, like I talked about before, it'd be great if we didn't even need to use the decorator, but instead we could just overwrite the native error handling capabilities of Python. And I've done some experiments with that, more towards the opening up of a browser window, but I think we could apply that here as well. But anyway, if you guys are interested in seeing any of those ideas unfold, and maybe even using this in your own projects, even though it might just be more cool than it is applicable, drop a comment down below, leave a like, subscribe if you like content like this. All right, I'll see you guys in the next one.